Welcome in. Today we're cracking the code with what I like to call the solve easily method for algebra. You know when you look at a massive block of equations and your brain just completely freezes up? Yeah, we've all been there. But in this explainer, we're going to break things down so you can just do, explain easily, and honestly, never sweat these types of problems again. It's totally foolproof, I promise. Just take a look at this. We've got subtract 4x squared minus 5xy plus 7y from the sum of, well, you get the idea. Seeing this giant jumble of handwritten math squished together with English words, it looks terrifying. It's like reading a completely alien language. But okay, let's dive into this because we are going to break it down piece by manageable piece until it makes total sense. To tackle this, we really need a solid game plan. I want you to think of this like baking. When you follow a recipe, you don't literally just throw all the ingredients into the oven at the exact same time, right? No, you prep them. We're going to use our solve easily method to lower the cognitive load by handling just one ingredient at a time. It's 3 simple steps. First, we find the sum. Second, we set up the subtraction. And third, we combine the like terms. Boom, that's the whole shebang. But before we start cooking, we have to actually read the recipe correctly. There is a huge fundamental difference between saying subtract A and B versus subtract A from B. So the crucial point is, that little word from is actually a sneaky linguistic trick. It literally flips our mathematical order of operations. Think about it. If I say subtract 5 from 10, the math is 10 minus 5. Whatever comes after the word from is actually our base, so it goes first. Armed with that trick, let's hit phase 1. Because of that word from, we're going to take that very first expression, the 4x squared one, and we're just going to park it, put it in timeout. We can safely ignore it for a minute. Why? Because the problem tells us to subtract it from the sum of the other 2 polynomials, and we literally can't subtract anything until we know what that sum actually is. So let's clear our heads and just focus purely on adding those second and third pieces together. To find that sum the right way, we need to prep our ingredients. We're going to organize our equation by matching up the variables into nice, neat rows. We've got our x squared terms, our mixed xy terms, and actually pay super close attention here. This includes x squared y and x squared y. They look almost identical, but they are completely different beasts. And finally, we have our y terms. By grouping them like this, we're getting rid of all that visual clutter. Just treat them like matching shapes. Squares with squares, triangles with triangles. Easy. Okay, let's throw this into the mixing bowl. We've stacked our 2 expressions vertically, lining up those matching shapes perfectly. Notice how those mixed xy terms don't quite match? One is xy squared, the other is x squared y, so they get their own separate columns side by side. Now we just do basic addition straight down. The x squareds add up, those unique xy terms just carry right on down into their slots, and the y terms combine. See? This is just a logical extension of the simple math you already do every single day. We've officially found our sum. Awesome, we've got our sum. Now we're ready for phase 2, which means bringing back that parked expression for these subtraction. But wait a second, what actually happens to our signs when we subtract? Now, what's really interesting about this slide is that it points directly to the absolute most common trap in all of algebra. This is the hurdle that trips up literally everyone, but we're going to walk right around it. Here is that trap. When you subtract an entire polynomial, you aren't just subtracting the very first number you see. Look at that incorrect example. They just subtracted the 4x squared and called it a day. No way. To do it right, you have to distribute that negative sign to every single term inside those parentheses. I want you to picture the minus sign outside as a giant reverse switch for absolutely everything inside. Let's see that reverse switch in action. We are subtracting our parked expression. And this brilliantly illustrates exactly what happens when we distribute that negative. The positive 4x squared flips to a negative. The negative 5xy flipping to a positive. And that positive 7y becomes negative. It's like flipping a coin for every single piece. And now for the grand finale. Let's stack everything up vertically again. We take our sum from phase 1, and right underneath it, neatly aligned by those matching shapes once again, we put our newly distributed subtraction from phase 2. Now we just combine them straight down the columns. The x squareds come together, the mixed terms drop on down, and the y terms consolidate. It's honestly effortless once it's set up like this. And there it is, our final answer. 4x squared minus 9xy squared minus 4x squared y plus 5xy plus 2y. Look at that massive, impressive polynomial. Literally just a few minutes ago, that was a terrifying, tangled sentence of handwritten math. But by using our solve easily method, finding the sum, carefully flipping our signs, and stacking those matching shapes, we made an incredibly complex problem feel like an absolute walk in the park. You totally cracked the code. By breaking down the language of the problem and just handling one single operation at a time, you successfully conquered a multi-step algebraic puzzle. Thanks for hanging out with me for this explainer. I want to leave you with this thought. If math really is just a language, what other intimidating sentences out there are just waiting for you to translate them into simple, logical steps? Until next time, just keep taking it one step at a time.